Hello students, welcome to our mathematics class. Again, in our mathematics class, we're going to be looking at another topic which is symmetry and three-dimensional shape. In this class, we're going to be looking at definitions of symmetry, different types of symmetry that we have, the class activities related to the topic, and also past questions. We have our interactive content here that will serve as a guide for this class. Okay, when you're talking about symmetry, a line of symmetry divide two-dimensional flat shapes into two congruent, identical shapes. Earlier in the previous class, we made mentions of congruent shapes. When you have the same size, corresponding size are equal, and some corresponding angles are also equal. Then we says that type of shapes as a congruent shapes. Okay, so when we have a line of symmetry to divide two-dimensional flat shapes into two congruent identical shapes, then we are talking about a line of symmetry. Now let's look at this. This is a shape here. It's just we have a plain line here, and they divide this shape just one. So we call this one line of symmetry. And if you look at tree, this one we are divided this shape into two. We have 1, 2, so we call this two line of symmetry. And if you look at this, we have 1, 2, 3, and 4. Then we call this type of line 4 line of symmetry. Okay, now we want to look at different type of symmetry that we have here. The first one here is what we have, the plane symmetry. Now a plane symmetry divided what divided three-dimensional solid shape into two congruent solid shapes. Now, remember we said that congruent shapes have corresponding size are equal, corresponding angle as well as equal. So let's have that at the back of our mind. So now for a plane of symmetry, a plane symmetry divide what? It divides three-dimensional shapes into two congruent solid shapes. So what plane symmetry do is that it divided shapes into two different congruent shapes that have the same line length and the same the same angle. Okay, so if that is it, let's look at, we have an example of a cubeboard there. This cubeboard I divided this cubeboard into what? Into two. So we have it divided into two different congruent solid shapes. So if you look at this one, this is the first part of it. You can call this a cube or another cubeboard. And if you look at this, after division, this is the first plane line. This is the second symmetry for the first shape. Look at the second cubeboard here. This is the first line here. This is the second one. And we have this divided into what? Into three. And if you look at this, the plane line can actually be, if you look at it, it has at least how many planes of symmetry here? We have at least 3 planes of symmetry. If you want to, this is 1, 2, and 3 for the first shape. We have 1, 2, 3 for the second shape. Okay. When you're talking about reflective symmetry, reflective symmetry, a shape has reflective symmetry if it has one or more lines of plane of symmetry. So if we have one or more lines of or planes of symmetry, then we say that that shape has a reflective symmetry. Now let's look at the square here. Let's count how many planes of symmetry that we have or lines of symmetry that we have here. How many is that? We have 1, 2, 3, and 4. So this is an example of a reflective symmetry in the sense that we have more than one planes of symmetry in this square shape. Okay, now we're talking about our rotational symmetry. A two-dimension shape has rotational symmetry. Okay, when rotated about a central point, it is identical to the to the original shapes and the orientation. So when you're talking about our rotational symmetry, you have two-dimensional shapes, and after you have actually rotated it, you rotate it about a central point from the original point, then it is actually identical to the original shape, then we say that that type of symmetry is a rotational symmetry in nature. Okay, now we have an example here. If you look at it, this is what? This is rotational symmetry of two order. After rotation, after we rotate this shape, you can see that we still have something like a triangle here, and we have a triangle here. And if you look at this shape, this is rotational symmetry of order of 4. That is, this is the first rotation, the second rotation, the third rotation, and the fourth rotation. And if you look at this, after rotating this shape, you still have a structure of a square. Look at this, this is a square, a square, and a square, and a square in nature. So we call this set of rotation a rotational symmetry. So two-dimensional shapes have rotational symmetry if when we rotate it, okay, about a central point, okay, it is identical to the what? To the original shape and orientation. So after you might have rotated a shape within the center, then we still have it in nature of the original shape, then we call it a rotational symmetry. And the number of times it does this during the complete revolution is called order of rotation symmetry. So number of times a shape is being rotated and it's complete a revolution is called what? It's called order of rotational symmetry. Okay. Now let's look at these class activities. We have to identify the lines of symmetry or plane of symmetry of these shapes below. Let's look at it. Let's count this first shape. How many lines of symmetry do we have here? We have 1, 2, 3, 4, okay, and 5. We count like this. This is the first one. Look at it. It comes out. The second one goes this way. The third one goes this way. The fourth one goes this way, and the fifth one goes there. So this one has 5 lines of symmetry or 5 planes of symmetry. Now let's look at this shape here. This is a pentagon, right, under quadrilateral, and this is a square. Okay, so we have how many lines here? 1, 2, 3, and 4. So this square we have 4 lines of symmetry. Now let's look at let's see if we are right. Okay, we are right. Now let's look at the next activity that we have here. We want to check the order of this symmetry. Okay, now how many is this? Now first and foremost, before we even identify the line of symmetry, what is the name of this shape? This is what? This is a rectangle. Okay, we have this to be rectangle. Now, how many lines of symmetry do we have here? You have 2 lines. Okay. Now let's look at it. What's the name of this shape? This is what? This is a triangle, right? Okay. How many lines does this have? We have 1, 2, 3. So we have 3 lines of symmetry. Let's check if we are right. Okay. Let's check. Wow, we are good. Now we are looking at what these are properties of a circle. We have looked at circle in our previous class as well. So for a circle, we call it what? A round curved shape. That was the definition we gave circle in the previous class. Okay, now look at this. We identify this side to be a chord. We identify this to be the radius inside the circle. Identify this to be diameter. And we identify this to be secant. And the other side, other part of the triangle is what we call tangent. So these are little properties of a circle that we have. Now, equal chords and perpendicular bisector of a circle. If chords, remember we located chord in the previous picture, which is located around this upper part of the circle. If chord AB and XY are equal, then here is AB, this is AB, and we have XY, this is X, and this is Y. So we have a chord XY, we have a chord AB. So if they are equal, then since OA, we have OA, OB, OX, and OY are radial, that is radius. So the triangles AOB, this is a triangle here, triangle AOB, sum of the triangle is 180 degrees. Remember, triangle AOS, another sum of the triangle is what? Is 180 degrees. So it makes this circle what? 360 degrees. They are said to be what? Congruent isosceles triangle. And it follows that the sections of the line of symmetry OM. So we have a line of symmetry here divided OM, and we have another one here which is what? ON. They are said to be perpendicular bisector of what? AB and what? And XY respectively. Okay, and let's look at tangent from an external point. Remember the picture of the circle property we showed the other time? The outer part of that circle we drew a tangent. So we want to look at tangent of what? An external point. Tangent OAC. Oh, this is OAC. It is a right angle triangle. We look at it as 90 degrees. And tangent OBC, another right angle triangle. Remember, we made mention of the properties of congruent right angle triangle on the other side. So they are congruent since angle OAC and angle OBC are what? They are right angle. So hence, we can now say that AC is equal to what? BC. So we have the same corresponding size of the sides are the same. That is, the side BC is the same thing as side AC. So let's use the right hand side of the process. This is going to be right angle triangle, angle OAC and angle OBC are right angle triangle, and side AC is equal to side BC. So they are congruent in nature. In general, tangents being drawn to the circle from an external point, they have equal length. Now let's look at the past question that we have here. Okay, we have this past question here, and let's solve together. Kate describes a quadrilateral. Remember, in the previous class, we mentioned a quadrilateral. Quadrilateral is a polygon that have what? That have 4 sides. Okay. Now, all the sides are the same length, and it has only 2 lines of symmetry. Draw a sketch of this quadrilateral. So, let's look at it. What type of quadrilateral is going to be that? If you look at the property of a rhombus have 2 sides. Those sides that are what? That are of the same length. So if you look at kites have all the 4 sizes the same. A square has all the 4 sizes the same. So it's going to be a rhombus because it have the same length. 2 sides are the same. And the only thing that you can get from a rhombus is what? Is just 2 lines of symmetry. So this rhombus satisfies that condition. So let's sketch the rhombus here. This side we have the same length. This side, okay. So we have our symmetry in this form, which is just 2 lines of symmetry. This drawing is just a sketch. Now we are now told that we should write down the mathematical name of this quadrilateral. We've done that already. The third one now says that we should what? We should calculate the angle if one of the interior angle of this quadrilateral is what? 70 degrees. So I remember I said that is a rhombus. So let's assume that if this side is 70 degrees, this side as well also 70 degrees. We don't know this. Let's assume this is x, and the other side as well also is x. So if that is the case, the sum of that rhombus is going to be what? The quadrilateral is 360. So we have it to be what? 70 degrees plus 70 degrees, right? Okay, plus x. Remember, they are also in degree, equals to what? 360 degrees. 70 plus 70 will give us 140 degrees. X plus x will give us what? 2x equals to what? 360 degrees. We want to get x, so we are taking 140 degrees to the other side, and it changes to what? It changes to minus 140 degrees. So 360 minus 140 degrees. What's that? That is going to give us 220 degrees. We want to get x out there, so we divide the both sides by what? 2. We divide the other side by 2, so we cancel it out. 2 we cancel 2, we have x. 2 can go in 220. How many times? That is 110 times. That is 2 in 2, 1, 2 in 2 in 1, and 2 in 0 equals 0. So our s is going to give us 110 degrees each. This takes us to the end of our class. We want you to subscribe to our channel www.edubbey.com for the full interactive content of this class. Thank you.